All right. So in this video, we're going to define what sine, cosine, and tangent are. We're going to be looking at basically only right triangles, all right, for a little while. All right. You could call this right triangle trigonometry if you wanted to. So I've got two right triangles here. In this right triangle, I'm going to define that angle to be theta. All right, so from my point of view, I'm looking from that angle. All right, so the way this works is from that angle, you have three sides of the right triangle. So the longest side, the one across from the right angle, that's always your hypotenuse. All right, and the way it works from here, the one straight across from it, we're going to call this side the opposite side. And this other side, we're going to call that the adjacent side. All right, so adjacent. Sorry, too long of a word, but yeah, just adjacent means right next to or connected to. All right, so like my room here in this classroom, it is adjacent to Miss Hudson's room, or it would be adjacent to the esports room, right next to it. And then that's kind of the definitions. We're going to use these definitions to talk about sine, cosine, and tangent. All right, so it really just depends on which angle you define theta as. So I could have defined theta to be this other one. So theta could be this smaller acute angle. All right, so now from this perspective, this side would be my opposite side. And this side would be my adjacent side. And then this one would still be my hypotenuse. So no matter which way you cut it, that's still the hypotenuse. So I think, I don't know when they teach it now, but probably in 8th grade maybe, you probably talked about the Pythagorean theorem. So the Pythagorean theorem gives you a relationship between all three sides of a right triangle. A squared plus b squared equals c squared. The trig functions, sine, cosine, and tangent, what these are going to give you is a ratio of one side of a triangle to the other side. So it's, I don't know, a ratio could be your miles per hour. It's miles over hours. So ratios are just fractions. So sine is going to give you a fraction for one of these sides over the other. So sine, sine of theta, or just sine in general, it's defined to be the opposite over the hypotenuse. All right, so if we were at this angle, sine of that angle would be whatever this is over whatever that is. All right, and then cosine would be defined as adjacent over the hypotenuse. All right, so again, if we were at this angle, it would be whatever this side is over the hypotenuse. And then the third one is tangent. All right, so tangent of theta, that's defined to be opposite over adjacent. All right, so whatever this side is over that side. So if these were numbers, which we'll do an example here in a second, but if these were numbers, then all of these trig ratios would represent fractions. All right, they'd be like 1/2 or 3/4, 3/8, some fraction. All right. The mnemonic for what you usually remember these, the way you remember them is SOHCAHTOA. All right, so SOHCAHTOA, spelled out like this, so the H is kind of silent here. So sine is opposite over hypotenuse, and that's what we had there. Cosine is adjacent over hypotenuse, and then tangent would be your TOA, would be opposite over adjacent. That's the most common way that people use to kind of memorize these. Anyway, we're going to use we're going to use these trig ratios here to find sine, cosine, and tangent for this right triangle. All right, so here's my right angle, 13 is my hypotenuse, and I haven't defined a theta yet. I'm just going to use, this smaller angle over here. I'll call it x. All right. So I'm looking from x's point of view. If I want to know what sine of x is, well, sine is equal to the opposite over the hypotenuse. So the side opposite x would be this 5, and the hypotenuse would be 13. So sine of x would just be 5 over 13. Right? So it's just a fraction. And cosine of x, that's going to be adjacent over the hypotenuse. So from x, the side adjacent to that would be the 12, because it's the one connected to that angle. It's the side that's connected to it. So 12 over 13. And then tangent of x would be opposite over adjacent. So that's going to be 5 over 12. All right. Now another common way that they define tangent, tangent can also be defined, I'll leave out the theta here. Tangent could also be defined as sine over cosine. All right, this is it's going to be pretty helpful later. You can use this relationship to find sine of x or cosine of x. If you know tangent of x, it's kind of a handy tool here. So instead of defining tangent of x to be 5 over 12, which that's obviously easy, you could define it to be sine over cosine. All right, so if you stacked 5 over 13 over 12 over 13, sine over cosine, what happens is these 13s just cancel, and you're left with the 5 over 12 again. So that's another way that we define tangent. Instead of opposite over adjacent, you can think of it as sine over cosine. All right, do some more examples here in a moment.